Welcome, everyone. Today, we're going to walk through how we designed and built a cloud analytics platform using AWS native services. This session is about understanding how modern data architectures come together, how we can use services like DMS, DataSync, S3, Glue, CloudWatch, Redshift, Athena, and QuickSight to create a fully automated analytics environment. We'll see how each layer, from ingestion to transformation to visualization, fits into one cohesive system that's scalable, serverless, and secure by design. By the end, you'll understand how all these AWS components connect to form an end-to-end data platform that continuously ingests, transforms, and deliver insights without manual effort. Here's the roadmap for what we'll cover today. The business challenge that led us here, ingestion, how we bring data from Oracle, on-prem CSV files, and vendor SFTP feeds into AWS. Storage and zones, how we organize that data inside Amazon S3. Transformation, how we clean, conform, and enrich using AWS Glue. Serving layer, how we expose the refined data through Redshift, Athena, and QuickSight. Orchestration and scheduling, how the pipeline runs hands-free. Monitoring and operations, how we keep everything healthy. Security and compliance, how we protect sensitive information. Then finally, we'll close with key takeaways and next steps. Now that we know what we're building, let's look at the scenario that brought us here. Client operates in a highly regulated data-driven industry with multiple disconnected systems, and their data was everywhere. They had an on-prem Oracle database, weekly CSV exports from internal tools, and daily vendor feeds arriving through SFTP. Their analysts and data scientists were spending hours merging sheets, waiting for manual refreshes, and struggling to get a single version of truth. So, our objective was to design a simple, resilient, and fully automated cloud data platform that would consolidate all sources into one governed environment, structure data into clear bronze, silver, and gold layers, automate ingestion, transformation, and orchestration end to end, deliver fast, secure analytics that refreshes automatically for everyone in the organization. To achieve this, we leveraged AWS managed serverless services, things like S3, Glue, Redshift, Athena, and QuickSight, which handle scaling, scheduling, and monitoring for us. That's what allows this platform to run hands-free while remaining compliant and cost-efficient. Now let's look at how data actually gets into our cloud environment. The ingestion layer is the foundation of everything. This is where we bring in raw data from our three sources and land it safely in Amazon S3. Let's walk through each one together. For the Oracle data, we use AWS Database Migration Service. DMS lets us replicate data continuously from on-prem databases into S3 without disrupting production systems. Let me walk you through the Oracle database setup. We start by spinning a DMS replication instance inside our private VPC so it can securely connect to Oracle. We make sure that subnet group points to private subnets and that the security group allows inbound traffic only on Oracle's port from our VPN or Direct Connect. Then next, we create our source endpoint. We enter the Oracle's host, port, and service name, but we store credentials in AWS Secrets Manager, never in plain text. DMS pulls them dynamically at runtime. Then we set up our target endpoint, which points to our S3 bucket. Then we choose Parquet as the output format, attach an IAM role that grants S3 put objects on that prefix, and enable SSC KMS encryption with our customer managed key. Finally, we configure that DMS task in full load, plus change data capture or CDC mode. That means DMS copies existing tables once, then streams every new insert and update continuously. We define table mappings, enable CloudWatch logging, and start replication. Once the task is running, we watch replication latency in CloudWatch. When it says near zero, let's say, we know our CDC is healthy. At that point, data from Oracle is flowing continuously into our bronze layer in S3 without us having to do a thing. The beauty of DMS is that once it's configured, it runs hands off. It keeps the S3 data continuously updated with minimal lag. Next, let's automate our internal CSV drops. We deploy a DataSync agent on-prem as a VM and activate it in AWS. Then we create a source location pointing to the file share where the CSVs land and a destination location pointing to S3. We enable SSE, KMS, encryption, and attach an IAM role with upload permissions. When we configure the data sync task, we choose incremental mode, so only new or changed files move. Set verify mode to full checksum for integrity and schedule it, let's say, every Friday at 1 a.m. We enable CloudWatch logging so we can see transfer metrics and errors. After each run, an EventBridge rule automatically triggers a Glue crawler to scan that S3 prefix and update the Glue data catalog. So every new CSV drop is discoverable within minutes. No manual work, no missed files, nothing. Now, for our external vendors, we don't want to maintain an SFTP server ourselves. Instead, we set up AWS Transfer Family to receive files directly into S3. We create a Transfer Family SFTP server inside our VPC with private connectivity and restrict access to vendor IP ranges. Each vendor gets an SSH public key, and it is mapped to an IAM role that grants write access only to that S3 prefix for that specific drop. All uploads are encrypted with KMS, and CloudTrail records every put for audit. We also set up an S3 object created event to trigger a glue crawler and ETL job that converts those CSVs to Parquet and Silver Zone. Within minutes of a vendor upload, their data is cataloged and ready for query. When we finish ingestion, we have all our raw data landed in one place. Amazon S3 under three prefixes. Bronze for the Oracle database prefix, another prefix for Bronze on-prem files, and another prefix for the Bronze vendor SFTP drops. Each is partitioned by date and source, making it easy to trace lineage and manage governance. Then now let's organize this data so it is useful for analytics. Now, once everything lands in S3, we organize it into three zones: bronze, silver, and gold, known as the medallion architecture. This structure turns our data lake from a dumping ground into a controlled, governed platform. In the bronze zone, we store data exactly as it arrived, raw, append only, and time-stamped. We never modify or delete from bronze. If we need to reprocess, we can always return to this ground truth copy. This approach protects traceability and meets audit requirement. Now, next, in Silver, we standardize and clean our data. Using AWS Glue ETL jobs, we convert CSVs to Parquet, normalize column names, fixed types, and join lookup tables. We store data partitioned by, let's say, business domain and date. We also use glue crawlers to periodically scan the silver zone and update schemas automatically. This is how we handle schema drift. If Oracle adds, let's say, a column or a CSV changes its format, the crawler detects it and creates a new schema version in the catalog. That way, nothing breaks downstream. Then finally, the gold zone, which is where we produce subject area datasets for business use. These tables are clean, aggregated, and optimized for analytics. For example, let's say client profitability, or daily market performance, or client demographics, etc., and so on and so forth. They're all stored in a columnar format like Parquet or ORC and cataloged with explicit schemas. For governance and asset capabilities, we can enable Apache Iceberg or Delta Lake on top of S3. Iceberg lets us perform upserts and time travel queries, which is great for late arriving CDC updates from DMS. This brings warehouse grade abilities to our S3 data lake. And here's the thing, across all three zones, we use the AWS Glue data catalog as our central metadata store. Each time a Glue crawler runs, it updates tables and partitions so Athena and Redshift Spectrum can query data directly from S3. We can even layer AWS Lake Formation on top of the catalog to enforce fine-grained permissions. For example, masking PI columns or restricting access to specific tables. The result is a data lake that's structured, searchable, and secure without losing flexibility. Now that our data is organized, let's transform it so it becomes trusted and analytics ready. We'll use AWS Glue ETL jobs running on serverless Spark to do this. We start by reading from the bronze layer using the Glue catalog as our schema source. Then we enforce schema consistency, standardizing column names and data types so all sources line up. Then next, we clean the data by dropping duplicates and invalid rows, and we add data quality checks for row counts, nulls, and expected values. If a dataset fails validation, we route it to a quarantine prefix for inspection. Then we enrich and conform. For example, joining market data from vendors with client records, adding lookups, and computing derived fields like region or risk score. When the data passes validation, we write it out to silver for clean and standardized records, and gold for curated ready for analytics. We store everything as Parquet, partition, let's say by date or business domain, and then update schemas through glue crawlers, data catalog crawlers, sorry. If we need upserts or let's say time travel, we can enable Apache Iceberg on our S3 tables to get ACID capabilities. No. Now our data is clean and organized. Let's see how we make it useful for analysis. We serve data through three AWS services that work together: Redshift, Athena, and QuickSight. We use Redshift for high performance analytics, and so we don't have to manage clusters. Redshift connects to our gold layer through Redshift Spectrum, and it lets us query data directly on S3 without copies. For, let's say, heavy dashboards, we use a Lambda function to run nightly copy command that load fresh partitions into internal storage. This way, by let's say 8 a.m., our dashboards are up to date. We use Athena for ad hoc analysis and data validation because Athena reads Parquet files in S3 using the Glue catalog. It's serverless and cost efficient, and it requires no infrastructure and also respects lake formation's permissions. Partition pruning and columnar compression make queries fast and cheap, cost efficient, very important. It's great for exploration and debugging without moving data. Finally, for dashboards and BI, we visualize our data in QuickSight, connecting it to Redshift or Athena. We enable Spice, QuickSight's in-memory engine, so dashboards load instantly. We build dashboards like, let's say, portfolio performance, market impact, and revenue analysis. The important thing is that all three services use the same schemas from the Glue catalog, so fields and definitions stay consistent everywhere. Now, let's automate the entire pipeline so it runs without human intervention. We use AWS Glue workflows to chain together all our tasks and schedule them through EventBridge. Here's how it runs step by step. We start with a daily 1 a.m. trigger in EventBridge that launches the Glue workflow. So, step one, it checks our DMS task latency to make sure CDC is caught up. Then it waits for the data sync transfer and vendor uploads to finish. So, the workflow uses Lambda pullers to monitor those tasks. Once ingestion is complete, it runs the transformation job to clean and curate data, which reads from bronze, writes into silver and gold layers, and registers schemas. Then it runs crawlers to refresh the catalog and update schemas for silver and gold. And finally, EventBridge triggers a Lambda function that executes copy commands to Redshift so dashboards show fresh data by the morning. If any step fails, the workflow pauses and sends a SNS alert to our Slack channel and email group. This way, the pipeline is completely hands off and is self healing. So now that our pipeline runs automatically, let's talk about how we keep it healthy. In production, visibility is everything. We need to see what's happening, get notified the moment something fails, and know who changed what. So, for monitoring, we instrument the entire pipeline using native AWS tools. CloudWatch for logs, metrics, and dashboards. SNS for alerts and notifications. CloudTrail for auditing, API activity, and also built-in health metrics from Glue, DMS, DataSync, and Redshift. So let's start with Glue jobs and crawlers. Every Glue job in crawlers streams detailed logs to CloudWatch logs, runtime, DPU usage, row counts, and errors. We tag each job by pipeline name so we can filter easily in CloudWatch log insights, and we set alarms on metrics like job failures and or job duration. If a job fails, SNS sends an email and Slack alert. If runtime spikes, for example, we know to check data volume or schema drift. Now, for DMS, we track replication latency and error counts through CloudWatch. If replication lag stays above 10 minutes for let's say 15 minutes, SNS alerts the data ops channel. We also monitor replication instance storage so we never hit capacity midstream. That's very important. Now, let's move to data sync. For AWS Data Sync, each task emits metrics like file transferred, bytes verified, and task status. We set alarms for failed or long running tasks. A small lambda compares expected versus, let's say, actual file counts after each run and posts a summary to the ops dashboard. Next is AWS Transfer Family or SFTP. So, vendor uploads are fully audited through CloudTrail and S3 access logs. Each new file triggers a Lambda that posts to our vendor upload Slack channel. So the team sees arrivals in real time. So they're always alerted. For Redshift and Athena, in Redshift, we enable query monitoring rules and track CPU and query duration metrics. In Athena, we watch bytes scanned per query to spot missing partitions or insufficient scans before before costs climb up. So for auditing and compliance, let's say, all API calls are captured by CloudTrail and stored for a year in a versioned S3 bucket. AWS config tracks configuration drift. If, let's say, someone disables encryption on a bucket, we're alerted immediately. Now, next, our CloudWatch dashboard shows job status, DMS lag, last data sync run, glue duration, and weekly success rates. At a glance, we can see if data is current and performing well. This is very important. So you always need to set up your CloudWatch dashboard. And for some quality checks, each glue job logs source to target row counts, duplicate rates, and null percentages. We publish these as custom CloudWatch KPIs. So if, let's say, record counts drop unexpectedly, we get a data quality alert before analysts see bad data. So, in short, CloudWatch gives us metrics and dashboards. SNS plus Slack keep us notified. CloudTrail plus config covers auditing, and custom metrics protect data quality. With these layers in place, we always know the health of our pipeline and fix issues before they impact users. Finally, let's look at security, which we built in from day one. Everything in this architecture follows the principle of PI by design. Privacy and protection aren't an afterthought, they're embedded at each and every layer. So, for encryption, all data is encrypted at rest and in transit. So, for example, S3 uses SSE KMS with customer managed keys for each environment. So, now for Redshift snapshots are also encrypted too. And all transfer services like DMS, data sync, transfer family uses TLS 1.2 for secure connections. Now, for network isolation, all services run inside a private VPC. We connect S3, Glue, and Secret Manager through VPC endpoints or private link, so traffic never leaves the AWS backbone. Our Oracle connection uses VPN or Direct Connect, and the SFTP endpoint is restricted to vendor IP ranges. Also, security groups and a CLS follow least privilege rules. For secret and access control now, we store all credentials in AWS Secrets Manager and assign each service its own IAM role with minimal permission. So, for example, Glue writes only to silver and gold, DMS only to bronze, no static keys are used. This isolated design limits blast radius if any component is compromised, which is extremely important. Now, for governance and auditing, on top of the Glue catalog, we use lake formation for table and column level permissions. In Redshift, we apply RBAC, which is role based access control, and also role level security so users see only authorized data. For example, let's say a banker views only their region's clients. They cannot view other clients. They're restricted to see only their own clients. We also enable dynamic data masking so PI fields like, let's say, account numbers appear obfuscated unless explicitly allowed. For auditing and compliance, every API call is logged by CloudTrail and stored for a year in an immutable S3 bucket with object lock. So, an AWS config monitors security rules. So, for example, if a bucket loses encryption or becomes, let's say, public, we get an immediate alert. Optionally, also, we can add Macy for PI scans and guard duty for anomaly detection. The goal is complete traceability and continuous compliance, which is extremely important in every architecture design. Sorry, guys. So to sum up security, everything is encrypted, isolated, and audited. Secrets are centrally managed, permissions are least privilege, and compliance is automatic. We don't just build secure systems, we build systems that stay secure by default. And this is always the goal. Now, what you see on the screen is a simplified version of the design to help you understand the entire picture of the final workflow. Now, let's bring it all together. What we've just covered is a complete production grade cloud analytics platform on AWS built for reliability, automation, and security from day one. Here's a quick recap of what we've built: automated data flow from Oracle with DMS, on prem files with DataSync, and vendor feeds with Transfer Family. Organized everything into bronze, silver, and gold with schema evolution handled by Glue Data Catalog and crawlers. Glue ETL jobs cleaned, standardized, and enriched data, while Iceberg gave us asset control and time travel. Redshift, Athena, and QuickSights delivered analytics fast and securely. Glue workflows and EventBridge ran the pipeline end to end with error handling. CloudWatch, SNS, and CloudTrail provided real-time visibility and quality alerts. KMS encryption, VPC isolation, secrets manager, lake formation, and RBAC ensured security, compliance, and auditability. Every component plays a specific role in creating a resilient, transparent, and cost-efficient platform. What makes this architecture successful isn't just the tools, it's the principles behind them, into which you always need to think about it when you are designing a solution. Automation over intervention. Let the system run itself. Governance over chaos. Everything has got to be tracked and cataloged. Scalability without complexity. Always avoid complexity. All layers are serverless and on demand. Make sure of that. Security by design, protection, and auditing are built in from the start. Since day one, you gotta think about security and design and governance at every single step and layer of your solution. See, this design's blueprint can grow easily. We can add, let's say, for example, a real-time streaming with the Kinesis or MSK, machine learning with SageMaker or Gold datasets, and CI/CD automation for Glue and infrastructure using CloudFormation or CDK. To wrap up, we transformed a manual disconnected environment into an automated governed analytics platform that delivers insights every morning without fail. You see, that's the power of AWS when it's designed right. Everything works together, scales automatically, and keeps data safe. Again, thank you for joining me. I hope this walkthrough helps you um, see not just how we build these systems, but how to think like an architect when designing for automation, governance, and trust. Again, thanks. Please like, share, and subscribe for more videos. See you next time.